Okay, now in this video we go over solving inequalities. So 5 plus a number x has to be less than or equal to 2. So whatever I add to 5, the result has to be less than or equal to 2. So draw a number line 0 in the middle. And let's make sure all x's in the problem have a number in front. So this x here would put a 1 in front of that. And we make sure there's no parentheses. You can't have more than one x. That's not a problem. There's just a solo x. And we'll dot and circle that x term. So it's positive 1x. Now decide the sign needs to be switched. Now, I don't think it does because that 1 is positive. Okay, so don't switch it, but write it down here. Okay, you're just going to write less than or equal, same way. Add or subtract outside the circle. Well, yeah, remember, I'm looking over here. We have this 5 out here, so I need to minus 5, and I'd minus that from 2. Okay, so I've got 1 dot x, I've got the sign, and then 2 minus 5 is negative 3. Okay, now divide. So I'll divide by 1, and then I'm going to start writing down here. So now I have x. The sign doesn't switch, and the negative 3 divided by 1 is just negative 3. Okay, the order is correct. The x comes first, so that's good, and then graph it. So you got negative 3. Circle the lines there, so you want to fill that in, and the nose points this way, so the arrow goes this way. So that means x can be all numbers as long as they're either equal to negative 3 or less than 3. Number 2, negative 13x is greater than 26. So draw a number line with 0 in the middle. Make sure all x's in the problem have a number in front. Does it as 13. No parentheses, we don't have any. You can't have more than one x, so there's a solo x. Dot and circle the x term. And decide if the sign's going to need to be switched. Well, that's a negative, so yeah, it's going to have to. So that turns around. Okay, so now I divide by negative 13. And I want to fill that under there. And by the way, you don't have to add or subtract outside. You didn't have to add or subtract because all you had was the multiplied by negative 13. So I've got x, and 26 divided by negative 13 is negative 2. Okay, so negative 2, so circle, and then the nose goes that way. So you're going to go like this, and you don't want to fill it in because the line's not there. It can't be equal, just less than. Okay, number 3. Now I need to put that sheet to the side because now we're dealing with a fraction. So x divided by 5 is greater than or equal to negative 3. So make your number line, but then we need to start thinking differently. I'm going to want matching fractions here. Now, before I cross multiply and divide, I need to decide if the sign's going to have to switch. Now, is that 5 that is divided, that the x is being divided by, is that positive or negative? Because it's all about that number. Well, that's positive, so we want to leave the sign so it's the same way. And then I cross multiply and divide. I just take 5 times negative 3 divided by 1, and that's negative 15. So the x is still on this side, and then I have negative 15 is a critical number. Okay, so negative 15, and I'm going to want to circle, and the line's there, so fill it in, and the nose goes this way. So 15 or greater, negative 15 or greater. Okay, number 4, negative 6x minus 5 is less than 13. So draw your number line with 0 in the middle. Make sure all x's in the problem have a number in front, and then we have a negative 6 in front. No parentheses, there are none. You can't have more than one x, that's not a problem. There's just a solo x. Dot and circle that x term. Okay, now decide if that sign's going to need to be switched. Well, it's going to have to be because we have a negative there. So we want to turn that sign so it goes the other way. Add or subtract outside the circle if you need to. Yeah, we have this minus 5, so we're going to have to undo that by adding 5 to both sides. So negative 6 dot x, you got the sign, and then that's going to be 18. Okay, now divide, and you're going to fill it in under here. So we're going to divide by the negative 6. Okay, so I've got x, and the sign has been turned around, and 18 divided by negative 6 is negative 3. Okay, so negative 3 is a critical number, and it can't be equal because there's no line there, so don't fill in the circle, and then it would just go this way. Okay, number 5, 2x plus 16 is less than or equal to 3x minus 2. Draw the number line with 0 in the middle. Make sure all the x's in the problem have a number in front. I have a 2x and a 3x. Okay. No parentheses. Now you can't have more than one x. Well, that's a problem here because there's more than one. There's not a solo x. There's a 2x and a 3x. So I need to simplify this by combining like terms. Now, if they're on the same side, we're going to make our adding pyramid. But if they're on opposite sides, we're going to switch the right to the opposite. Well, they're on opposite sides. That's OPP for opposite. So I'm going to switch this right one to the opposite. And 2x minus 3x, 2 minus 3 is negative 1, plus 16, the sign, and then negative 2. Okay, now dot and circle your x term now that you have a solo x. Now decide if that sign needs to be switched. Well, the dot number is negative, so yeah, it does. Add or subtract outside the circle if you need to, or we need to, plus 16. So minus 16, minus 16. So I've got negative 1 dot x, the sign, and then negative 18. Okay, now it's time to divide by negative 1. So that cancels, and I'm going to want to put my stuff over here now. So I got the x, because it's when I divide the sign changes, because that's when everything, when I divide by a negative, the signs on everything change, so including the sign itself. So that's going to be positive 18. Okay, so the critical number's 18. Circle it. The line's there, so we'll fill that in, and then the nose goes this way. Okay, number 6, negative 20 is less than 9x plus 7, and that's less than 34. So number line. Okay, make sure all x's in the problem have a number in front. You do. You have a 9x. Is there any parentheses in the inequality? Nope. You can't have more than one x. That's not a problem here. I just have a solo x, 9x. Now dot and circle your x term. Decide if the sign needs to be switched. Well, there's two signs, and that 9's positive, so we're not going to need to switch either sign. We'll just leave them both the same way, both less than. Okay, add or subtract outside the circle. Now I'm going to cover up these numbers. I just want to look in between the signs here. Okay, do I have a number being added? I do, plus 7, so I need a minus 7. I'm going to minus 7 there, and then from the negative 20, and then from the 34. Because you have this, the middle, and this. It's like three sides. So what you do on the middle, you got to do to the outsides. Okay, so negative 20 minus 7, think of a number line. If you're at negative 20 and you move 7 deeper into the negatives, you're going to be at negative 27. And then the sign, and then 9 times x. Those canceled, and then the next sign. 34 minus 7 is 27. Okay, now we need to divide. So what number's multiplied by the x? 9. So I need to divide by 9, and that goes away. But then I need to divide negative 27 by 9 and 27 by 9. Okay, so that's negative 3. That's x, and that's 3. Okay, so those are my two numbers, negative 3 and positive 3. Okay, now on the graphing part, okay. This is tell you kind of the graph. It looks confusing, but this is what to do if x and y are on opposite sides, slope, y-intercept. They're on the same side. Use this. And these aren't really going to apply. I'm not going to put these on the test, so you can just ignore them. And then there's what to do with the true-false test. Okay, so here's the y and here's the x. Y is greater than negative 4x plus 3, so they're definitely on opposite sides of the inequality, so opposite. So I would want to use this procedure here, slope and y-intercept. Okay, the slope is the x coefficient, whatever's in front of the x, so that's going to be negative 4, but that always needs to be a fraction, so we're going to put a 1 in the denominator. And the y-intercept's whatever we're adding or subtracting to the x term, which is 3. Okay, we graph our y-intercept first, and it's either up or down. Well, this 3 is positive, so that'd be up. So 1, 2, 3. And then I use my slope, but I want to do that from the first point, okay, not from the middle, from the first point. So it's either up or down. Well, this would be down, and this would be to the right. So down 1, 2, 3, 4, right 1. And put a bar there. Okay, don't ask me why. I want a bar there because I want to make a solid line. Okay, now, if it's just an equals, then I can just leave my line and say that's it. All points on the line make the equation equal out to each side equal to the other. But this is an inequality, so I need to do my true-false test. So I replace the x and the y with zeros in this, okay? And where is 0, 0? Well, it's right here. Okay, so y, get that out of there, and that's 0. And the x, we'll parenthesize it, then we'll take it out, and we'll put in 0. Okay, so what do you have here? 0. Then you have your sign. Then you have negative 4. Then you have a parentheses, but you're going to put 0 in that parentheses. And then you're going to add 3. Okay. All right, so, well, this side has 0, and then my sign, and I need to figure out what that side equals. Well, negative 4 times 0 is 0, plus 3 is 3. Now, what's smaller? 0 is smaller than 3, so does the nose point towards the 0? No, it doesn't, okay? So that's a false statement, so that means this side of the is false, and the other side of the line is true. Okay, number 8. 2x minus 4y is greater than or equal to 16. So here's the x, and here's the y, and here's my sign. So they're on the same side. So I'm going to want to graph using the x and y intercepts. So I'm going to make a table with 2 points, 0 for x and 1 point, and then a 0 for y in the other. So to find the values that go here, we're going to want to write the equation out twice. 2x minus 4y, and then just put a regular equals 16, and then do it again. So if I have the x as 0 here, we can eliminate that. And if I have the y as 0 here, we can eliminate that. And then all I need to do is divide, because that's your dot, and divide. So 16 divided by negative 4 is negative 4. And then divide by 2, and 16 divided by 2 is 8. Okay, so I graph this point and this point. So the 0 means I'll stay for the x. Remember, this is the x, this is the y. So we'll stay, and then we will go down 4. So I stay, go down 1, 2, 3, 4. Okay, now when I'm doing a table, I'm going to go back to the middle. And the x, I'll go right 8 and stay. So 1, 2, 3, 4, 5, 6, 7, 8 and stay. And then I graph those 2 points. Okay, and that's my line. Okay, now we got to run our true-false test, and we're going to run it with the 0, 0 in the middle. Okay, so get that x out of there. It has a 2 in front of it, so I'm going to parenthesize and then put the 0. And the y, same thing. Okay, so now what does the inequality say? You have 2. Then you have parentheses with 0 inside. Minus 4. Then a parentheses with 0 inside. Then the sign. Then 16. Okay, well, 2 times 0 is 0, 4 times 0 is 0. I think that whole side ends up as 0. And then the sign, and then 16. Well, 0 is smaller. But again, the nose doesn't point towards a smaller number, so that's a false statement. 0 is not greater than or equal to 16. So that's false. And the other side's true.